The Chelyabinsk explosion 2013, a meteor's shockwave stronger than a nuclear bomb, yet damage mechanisms remain in debate. On the morning of February 15, 2013, Chelyabinsk, a quiet industrial city in Russia's Ural region, awoke under the familiar winter chill. Snow-blanketed rooftops, rivers lay frozen beneath a thin veil of mist, and residents prepared for an ordinary workday. No one could have guessed that within minutes, the sky above them would become the stage for one of the most astonishing cosmic events of the 21st century. At around 9:20 a.m., a blinding white flash tore across the sky. Witnesses later described it as a second sun blazing overhead, so bright that many instinctively shielded their eyes. The eastern horizon seemed to ignite, bathing the snowy streets in an eerie daylight. For a few seconds, confusion reigned. People stopped in their tracks, pointing upward. Then came silence. 2 long minutes passed. And then the real shock hit. A deafening blast reverberated through the city, powerful enough to shatter windows in thousands of buildings, peel plaster from walls, and knock people off their feet. An invisible wall of compressed air, a shockwave, swept through Chelyabinsk, hurling shards of glass and debris like invisible shrapnel. By the end of the day, over 1,600 people were injured, most from flying glass. More than 7,000 buildings sustained damage. The astonishing part? All of this destruction came from a meteor barely 20 meters, 65 feet, across. The journey of a cosmic wanderer. Scientists determined that the Chelyabinsk meteor was a space rock weighing roughly 12,000 to 13,000 tons, originating from the asteroid belt between Mars and Jupiter. It had wandered the solar system for millions of years, battered by smaller impacts and extreme temperatures. That February morning, it entered Earth's atmosphere at a staggering 19 kilometers per second, about 68,000 kilometers per hour. Friction with the air heated its surface to thousands of degrees Celsius, causing it to glow with intense brilliance. But instead of striking the ground intact, it exploded at an altitude of around 30 kilometers, 19 miles. This was an airburst, when a meteoroid disintegrates in midair due to immense pressure and heat. The Chelyabinsk explosion released energy equivalent to 400 to 500 kilotons of TNT, 25 to 30 times more powerful than the Hiroshima atomic bomb. Yet, because the blast occurred high in the atmosphere, most of the energy dispersed before reaching the ground. Shockwaves, the silent culprit. Unlike many meteor impacts, Chelyabinsk caused no massive crater, and no one was struck directly by falling space rock. Instead, the injuries came almost entirely from the shockwave, the sudden pressure front created when the meteor's explosion compressed the surrounding air. Shockwaves travel faster than sound, which is why people saw the flash first, then heard the boom much later. That delay proved costly. Curious onlookers walked to their windows to get a better view, only to be met with an onslaught of glass shards seconds later. Windows are especially vulnerable because of the abrupt pressure change. The wave first forces air against the glass, pushing it inward until it shatters, then sucks outward as it passes, sending shards flying in both directions. Not a nuclear bomb, but just as powerful. Despite releasing energy on the scale of a large nuclear weapon, the Chelyabinsk explosion produced neither radioactive fallout nor the classic mushroom cloud. Its energy came purely from kinetic impact, the conversion of the meteor's motion into heat, light, and pressure as it fragmented. Still, for a few moments, some people thought Russia might be under attack. The blinding light and thunderous detonation triggered Cold War-era fears, and military forces briefly went on high alert until the source was confirmed as natural. The meteor's remains. Following the blast, a rain of smaller meteorites fell to the ground and onto the ice of Lake Chabarkal. Months later, divers recovered a massive fragment weighing more than 500 kilograms, 1,100 pounds, from a lakebed. Analysis revealed that the Chelyabinsk meteor was an ordinary chondrite, composed mainly of silicate minerals, iron, and nickel. These minerals formed 4.5 billion years ago, during the birth of the solar system, making the fragments invaluable to planetary scientists. Unanswered scientific questions. More than a decade later, researchers still debate aspects of the event. One of the most puzzling is, why was the damage from the shockwave so severe, far beyond early computer model predictions? Some proposed explanations include irregular internal structure. Cracks and voids inside the meteor may have caused it to fragment in multiple bursts, each producing overlapping shockwaves. Shallow entry angle. The meteor approached at roughly 20 degrees, spreading the energy over a wider area. Terrain effects. Mountains and valleys in the Euro region may have reflected and amplified the shockwave's force. A warning from space. Chelyabinsk was the largest meteor explosion since the Tunguska event of 1908, and luckily, it caused no deaths. But it served as a sobering reminder. Earth is not immune to cosmic hazards. Most meteors under 50 meters across burn up or explode before hitting the ground. But airbursts like Chelyabinsk can still cause mass injuries if they occur over populated regions. What's more troubling is that this meteor was completely undetected before impact. It approached from the direction of the sun, a blind spot for most telescopes. In the aftermath, space agencies expanded programs to detect and track near-Earth objects, NEOs, hoping to spot threats early. Yet, the sheer size of the sky and the limitations of current technology mean that smaller, but still dangerous objects can slip through unnoticed. Conclusion. February 15, 2013 will be remembered as the day the sky over Chelyabinsk lit up, not from fireworks or warfare, but from a cosmic message. The meteor's flash and roar reminded us that our planet, though vast to us, is but a fragile vessel adrift in a cosmic shooting gallery. The explosion was both a triumph for science, providing rare data on meteor airbursts, and a wake-up call. Threats to life on Earth can come not only from ourselves, but from silent wanderers in space, arriving without warning and carrying energies far beyond any weapon we've ever built.